3 frameworks, all promise to help you build AI agents. All wildly different opinions on how, and all 3 have passionate communities ready to die on their respective hills. So which one do you actually pick, and more importantly, why? Because, spoiler, the answer isn't the same for everyone. Stick around. By the end of this, you won't just know what each one does, you'll know exactly which one belongs in your stack. Before we get into the frameworks, let's talk about why this decision is heavier than it looks. We're living in the agentic AI era. Everyone's building RAD pipelines, tool calling agents, multi-step reasoning systems, autonomous workflows. The gold rush is real. But here's what nobody tells you when you're excited about a new project. The framework you choose shapes everything downstream. Your developer experience, your debugging sessions, how readable your code base is 6 months later when someone new joins the team, how fast you can iterate, how much the abstraction layer helps you versus bites you when you hit an edge case. These aren't just libraries you can swap out on a Tuesday. They're philosophies about how AI applications should be structured. Picking the wrong one isn't just annoying. It's weeks of refactoring you didn't budget for, technical debt that compounds, and a team that slowly loses confidence in the tooling. So let's do this properly. Let's start with context, because understanding where something came from tells you a lot about what it optimizes for. LangChain arrived in late 2022, right when GPT 3.5 hit the world like a freight train. Harrison Chase released it almost as an experiment, a way to chain together LLM calls with tools, memory, and prompts. The developer community grabbed it immediately. It became the default glue layer, the thing everyone reached for when they needed to build something fast. Think of it as the jQuery of AI frameworks. Ubiquitous, slightly messy, incredibly powerful once you understand its quirks. By 2023, it had a massive community, a commercial observability layer called LangSmith, and a graph-based agent extension called LangGraph. It grew fast in every direction. LlamaIndex, originally called GPT-Index, launched around the same time but with a more specific obsession. How do you make your own data queryable by a language model? PDFs, databases, internal wikis, Slack exports, financial reports. Feed it all in, structure it properly, and get intelligent answers back out. It wasn't trying to be everything. It found its lane in data ingestion and retrieval, what we now call RAG, and it owned that lane deeply. It grew a TypeScript version alongside Python, built out a workflow layer called Llama Workflows, and eventually evolved into a broader agentic framework. But its DNA is still fundamentally about data. Mastra is the youngest of the 3, born in 2024. Built by the team behind Gatsby, people who had shipped real, large-scale production JavaScript applications. They were genuinely frustrated with the Python-first bias of the AI tooling ecosystem. They asked a simple question: what would a proper TypeScript native AI framework look like, built from scratch with modern developer experience in mind? No Python port, no afterthought JS bindings, first-class TypeScript from day one. The result is opinionated, focused, and honestly refreshing. It feels less like a library and more like a framework with a clear point of view. Alright, let's go deep on each one, starting with LangChain. The headline is breadth, 600 plus integrations. Every major vector database, Pinecone, Weaviate, Chroma, Quadrant, pgvector, every LLM provider, OpenAI, Anthropic, Cohere, Mistral, local Llama models. Every embedding model, every tool category. If it exists in the AI ecosystem, someone has already written a LangChain integration for it. That's genuinely impressive. The core abstraction is the chain, a composable sequence of calls. You pipe an input through a prompt template, into an LLM, through an output parser, and out comes structured data. Chains can call other chains. They can include tools, retrievers, memory. The composability is real. Then there's LangGraph, LangChain's graph-based agent framework. This is where it gets powerful for complex agentic systems. Instead of linear chains, you define a graph of nodes and edges, where nodes are functions and edges can be conditional. You get cycles, which means agents can loop, reflect, retry, branch. LangSmith is the observability layer. Trace your chains, debug your prompts, evaluate output systematically. In production, this matters a lot. Now, the honest downsides. LangChain has an abstraction problem. The magic that makes it powerful also makes it opaque. When something goes wrong deep in a chain, the error messages are often cryptic. Junior developers frequently hit walls they genuinely cannot debug. The JavaScript version has historically lagged behind Python in terms of feature parity and stability. If you're a TypeScript shop, that gap has caused real pain. And there's a size concern. It's a heavy dependency. For serverless environments or edge deployments, the bundle size and cold start times can be a real issue. The ideal LangChain user? A Python team, building complex pipelines that need breadth of integrations, willing to invest time in understanding the abstractions. Now, LlamaIndex. And this one deserves real respect for how clearly it knows what it is. If LangChain is trying to be everything, LlamaIndex is trying to be the best at one thing, making complex, heterogeneous data intelligently queryable by language models. And in that specific domain, it is genuinely world-class. The core concept is the index. You load data from anywhere: PDFs, Word docs, SQL databases, REST APIs, Notion pages, S3 buckets, web crawls, and LlamaIndex handles the ingestion pipeline. Parsing, chunking, embedding, storing in a vector database. And then the retrieval side: semantic search, hybrid search, keyword filtering, metadata filtering, re-ranking. It's all there, deeply configurable. The chunking strategies alone are a rabbit hole. Fixed size chunks, sentence window chunking, hierarchical chunking, semantic chunking that tries to keep related ideas together. These choices have a massive impact on retrieval quality, and LlamaIndex lets you tune them systematically. Query routing is another superpower. You can define multiple indices, one for your product docs, one for your customer data, one for financial reports, and build a query router that decides which to hit. That's real enterprise-grade RAG architecture, not toy examples. They also evolved their agent story with Llama Workflows, an event-driven, async native workflow system, better suited to teams that think in terms of data pipelines rather than graphs. Downsides? The agent story, while improving, still doesn't feel as first-class as LangChain's LangGraph or Mastra's workflow engine. If your application is more about reasoning and acting than about finding and retrieving, you might feel the limits of LlamaIndex's original DNA. The ideal LlamaIndex user? Any team where the core challenge is intelligent information retrieval, enterprise search, document Q&A, knowledge-based chatbots, research tools, financial analysis apps, and now Mastra. I want to spend real time here because this one is genuinely exciting and somewhat underrated right now. Mastra starts with a conviction: TypeScript developers deserve a first-class AI framework. Not a port, not a wrapper, something designed from the ground up for how modern JavaScript applications are actually built. The four core primitives are agents, tools, workflows, and memory. Simple, right? But the execution is what matters. Agents in Mastra are declared with a clean, typed API. You define the model, the tools it has access to, any instructions, and the memory configuration. What's notable is how readable the code is. You're not fighting abstractions, you're describing intent. Tools are defined with Zod schemas for both inputs and outputs. This is huge. Zod is the standard TypeScript validation library. Every TypeScript developer already knows it. Mastra gets automatic type safety, runtime validation, and AI-readable schema descriptions all in one. When your agent calls a tool, you know the data is the shape you expect. That eliminates an entire class of runtime bugs that plague other frameworks. Workflows are where Mastra really differentiates. The workflow engine lets you define multi-step processes as a graph of steps, explicit inputs, outputs, retry logic, conditional branching, parallel execution. Think of it as a proper orchestration layer, not just chaining LLM calls, but defining real business logic with reliability guarantees. Each step is typed. Data flows between steps are validated. If a step fails, you can configure retry behavior and fallback paths. Memory is first class, not an afterthought. Agents have working memory for the current session, and you can persist memory across sessions with built-in storage adapters. There's also a local dev server with a playground UI. Run your agents locally, interact with them, inspect their reasoning, test workflows without deploying anything. And Mastra integrates natively with Vercel AI SDK, which means if you're building Next.js apps and streaming AI responses to a front end, the integration is seamless. On its downsides, it's young. The ecosystem of integrations is smaller than LangChain's by a wide margin. You'll be more on your own when you hit an edge case. The RAG story is present, but not as deep as LlamaIndex. You can build RAG pipelines with Mastra, but if RAG is the core of your application, you'll want more than Mastra currently offers alone. The ideal Mastra user? A TypeScript or full-stack JavaScript team building agentic applications who want great developer experience and are willing to accept a smaller ecosystem in exchange for better ergonomics. Alright, let's put them in the ring together. Across 5 dimensions, developer experience. Mastra wins this cleanly. TypeScript native design, Zod validation, readable APIs, and the local playground make it the most enjoyable to work with day to day. LlamaIndex is solid, especially if you're comfortable in Python. LangChain has improved dramatically, but still carries abstraction weight. Breadth of integrations. LangChain wins, no contest. 600 plus integrations versus what Mastra and LlamaIndex offer is not a close comparison. RAG and data retrieval. LlamaIndex wins. This is its home turf. The depth of chunking strategies, retrieval methods, query routing, and re-ranking options is unmatched. Agentic workflows. Mastra wins for TypeScript teams. The workflow engine with typed steps, retry logic, and conditional branching is the most production-ready workflow primitive. LangGraph from LangChain is powerful but complex, excellent for Python teams building sophisticated reasoning graphs. Production maturity. LangChain wins by a large margin. Thousands of applications in production since 2022. The failure modes are documented. The community has hit the edge cases. Mastra is promising but young. You may be the one discovering the edge cases. So how do you actually decide? Here's the mental model I'd use. Ask yourself 3 questions. First, what language is your team writing? If you're Python, LangChain and LlamaIndex are both natural fits. If you're TypeScript, especially if you're on Next.js or a Node.js backend, Mastra is the obvious choice now in a way that didn't exist a year ago. Second, what's the core problem you're solving? If it's intelligent data retrieval, making documents, databases, or knowledge bases queryable, LlamaIndex is your answer. If it's building autonomous agents that take actions and run workflows, Mastra if you're TypeScript, LangChain's LangGraph if you're Python. If it's connecting many different AI services and providers together in a production system, LangChain's integration breadth is hard to beat. Third, what's your risk tolerance for ecosystem maturity? If you're building something where reliability and community support are critical, production systems with significant user load, enterprise deployments, LangChain's maturity is a real asset. If you're moving fast, experimenting, building internal tools where developer velocity matters more than ecosystem depth, Mastra's DX advantage pays off quickly. One more consideration. These don't have to be mutually exclusive. In complex architectures, it's not unusual to see LlamaIndex handling the data layer, with LangChain or Mastra orchestrating agents on top. They're composable systems. You're not locked into using exactly one. Alright, the verdict. Pick LangChain. If you're a Python team, you need maximum integration coverage, you're building complex multi-agent systems and want a battle-tested foundation. Pick LlamaIndex if your application is fundamentally about making data intelligently queryable. Document search, enterprise knowledge bases, multi-source RAG, financial document analysis. If retrieval quality is the competitive differentiator in your product, this is your tool. Pick Mastra if you're a TypeScript or full-stack JavaScript developer, you're building agentic systems, and you want the best developer experience available right now without fighting Python abstractions. And honestly, if you're a TypeScript developer who hasn't looked at Mastra yet, go look at it this week. The ecosystem is younger, yes, but the opinionated, well-designed API is genuinely refreshing after years of ports and wrappers. The team is shipping fast, and the DX is the kind that makes you actually enjoy building. The AI framework space is still young. These tools will all look different in 18 months. But right now, in 2025, those are the 3 honest answers, depending on who you are and what you're building. That's the breakdown. Mastra, LangChain, LlamaIndex. Each one a legitimate choice, each one built with a different developer and a different problem in mind. The worst thing you can do is pick based on hype. The best thing you can do is match the tool to the actual shape of your problem. If this was useful, share it with someone who's currently stuck on this decision, and drop a comment. Which one are you using, and what's your honest take? See you in the next one.